9-5 congruence. Okay, objective today is to recognize congruent figures and to state properly the congruence of each and to properly state the congruence of figures. Okay, what does congruent mean? Congruent, well, the symbol for it is an equal sign with a little squiggly thing up top of it. And that means same size and same shape, so it means equal. So here we have triangle ABC and triangle XYZ, and we're going to say that triangle ABC is congruent to this triangle, but when we do so we have to put the same corners or vertexes or the similar vertexes and corners in the same spot. So what matches up with A? That would be Y. What matches up with B? That would be X, and then Z matches up with Y. So we don't say it as triangle XYZ if we're calling triangle ABC. We have to put them in the same spot. Now if I have triangle XYZ, what matches up with X? Well, that would be B. What matches up with Y? A, and then we're left with C. So we can mix things around, but they have to match up, be put in the same spots, the corresponding spots with their congruent corners. Corresponding angles. So angle A corresponds with angle Y. Angle B corresponds with X. Angle C corresponds with Z. Corresponding sides, we have side AB goes with XY. BC goes with XZ. And AC goes with YZ. Again, they have to be the corresponding sides. Okay, types of rigid motion. If you're just sliding it over, that's called a translation or a slide. If you twist it, that's known as a rotation. And if you basically flip it over, that's known as a reflection because it looks like a mirror. So properly state the congruence of the polygons below. Let's do number 1 together. So if we say we have triangle ABC, what matches up with A? That would be Y. What matches up with B? Now the way I look at it, from A to B is the short side, so I'm going to look at the other triangle and I'm going to try to find the short side there. That would be Z, and then that leaves X. Would you try 2 and 3 on your own? Okay, so for quadrilateral we have LMNO. So let's see if you have that put in the same order. And then what matches up with L? L to me looks like a right angle, so I'm guessing that's going to be C. And then we have M. That's kind of the long right angle side, so that would be B. And then we have A and D. For triangle EFG, what matches up with EFG? Alright, so for E we have I, and then J and H. This can be a little tricky, so you do want to kind of pay close attention and make sure they're kind of matching up with what goes with each other. Now it may not always state, hey, this is a congruent triangle. Sometimes you have to prove it. And there are basically 3 different ways of proving that 2 triangles are congruent. The first one we have is what's known as side, 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 or for short we call it SSS. And basically what that says is if you have 2 sides that are congruent, then another 2 sides that are congruent, and then the other pair are congruent. So basically you have triangles that have the exact same sides, then they are congruent. Yeah. Okay, the next one we have is side, angle, side. Now with this one, again you have a pair of sides that are equal to each other. That's what the little dashes mean. You then have an angle next to it that's touching it to our equal sides that are equal to each other. That's what the little arcs mean. And then the other side touching the angle is also equal. So you kind of have an angle sandwich here. It's squished in by two pairs of sides that are equal. And that's side, angle, side. So we had side, 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 and then side, angle, side. Our next one, the congruent angle must be between the two sets of congruent sides. Again, we've got an angle sandwich here. Our last one is angle, side, angle. And angle, side, angle is kind of the opposite of the side, angle, side. We have a pair of angles that are equal, and then connected to that is one side that's equal, and then connected to that side is another pair of angles that are equal to each other. So again, the side has to be between the two angles, and that would make that congruent. Now, what we're going to do here is we're going to kind of play like a lawyer type of game. We want to tell if we don't know if these two triangles are congruent. And they look congruent, they look the same, but just by looking we can't always say that. But if we have certain pieces of information, we can use those to prove that they are congruent. So think of it as you're a lawyer and you have to offer 3 pieces of evidence. If you give them 3 pieces of evidence, then you can say, these are congruent angles. I've proved my case, they're guilty. So let's take a look at these two triangles and what do we know, what information do they give us with their little marks and their arcs. Well, we know that side MN is congruent to side PR. So that gives us a side. So the way I like to do it is I say, okay, well, what do I know? Well, I got a side. So it could still be either side, 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 angle, or angle, side, angle. Well, what else do I know? I know that side MO and side QR are also congruent. So that pretty much eliminates ASA. It's probably not going to be that, although it could be. So now I have 2 sides, so most likely it's either side, 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 or side, angle, side. Well, next I have this angle M and angle R. So they're congruent. They can tell that by the arcs. So that gives me an angle. So now I have an A, an S, and an S. I'm going to rearrange those so I don't get in trouble. And that gives me side, angle, side. So these two triangles are congruent. We've proved that they're congruent. We've given 3 pieces of evidence that prove that these two triangles are equal to each other. Look at this triangle and what information can you see that tells us that these two triangles are equal to each other? And we can't just say because they look like it, or they're touching, or they're pretty. We have to use solid evidence. So, what do we know? Well, I've got angle WAB and angle XAB. They're congruent to each other, so that's an angle. So I've eliminated side, side, side. It's not probably going to work here. What else do I know? I know that angle WBA and angle XBA down at the bottom, they're both right angles. Right angles are equal to each other. So now I have 2 angles. Now this is where people get a little bit stuck. So I have an angle and an angle. So that eliminates side, angle, side. That leaves angle, side, angle. Well, what side is between the two angles? That would be side AB. Well, they share side AB. So what do we know about AB compared to AB? We know that it's equal to itself. So AB is equal to AB. So that gives me my side. So I have angle, side, angle. So triangle WAB is congruent to triangle XAB by angle, side, angle. Now I'd like you to pause the video and try to get as much information as you can. Now I'm going to give you a hint. You're going to have to use some information from the last lesson. Okay, what evidence were you able to come up with? You should have at least been able to come up with 2 pieces of evidence. The first one I would say are the sides. Those are easy. BC is equal to CD. That gives me a side. What else do they give us? Well, we have angle B and angle D. They're congruent by the information they give us. Now the tricky part. Where's the unknown? Well, if you remember back to the previous lesson, we have these 2 angles are vertical angles. What do we know about vertical or opposite angles? That they're equal. Therefore, angle ACB is congruent to angle ECD. So now I have a side, an angle, and a side. So I can put that in the middle, and I get angle, side, angle. Therefore, triangle ABC is congruent to triangle EDC by angle, side, angle. Would you try to do as much of this one as you can? Well, we'll start with side AB is congruent to side DC. So that gives me a side. BC is congruent to AD, so that gives me another side. So I've got 2 sides, and then my last side, DB, is congruent to itself, BD. So that gives me my side, side, side. So triangle BAD is congruent to triangle CDB by side, side, side. Okay. If quadrilateral HIJK is congruent to quadrilateral NMLO, what matches up? Corresponding angles. Angle H. What goes with angle H? Angle N. And then the J, I, and M. The J and the L. The K and the O. And then sides, HI goes with NM, IJ goes with LM, JK goes with NO. And that's it. If you have questions, post them on Edmodo. And again, I want you to post that you've seen the video, so don't forget to do that. Thank you very much. Bye.